All right.
All right. Time for some GPU goodness with the Jetson. I think we already have a couple of people on, so we can probably get started. Should I start with a little overview of the hardware we got going on here?
Yeah, what exactly are we doing? Who are we and what are we doing here?
Everybody knows me. I'm world famous. No. so, um, you want to introduce yourself, Paul, being that you're joining me here?
Yeah, sure. I'm Paul DiCarlo, based out of Houston, Texas. Coincidentally, work on the same team as Mr. Eric, and we're here to test drive the Jetson Nano, and I guess see how easy it is to get up and running. Maybe try to get it to do something interesting. Hopefully, in the time that we have.
Yeah, I've been wanting to get more into machine learning and AI, and I'm a hobbyist electronics person. Over that direction, there's a whole electronics desk and a variety of generations of Raspberry Pis and Odroids and all kinds of stuff. And Paul was showing me some of the Jetson devices, and I started geeking out. And he was nice enough to send me one that we're going to play with today. If I scoot back here, we can take a look at it. I've got a quite zoomed in camera here. Is that just something that you did to it?
Well, I have hooked you up a little bit in terms of how the device comes. Normally, the dev kit ships with just the device itself. In the case of the Nano, which means that you get the carrier board with the attached SAW module. The few minor modifications that yours has, we have applied a jumper to one segment of the board that allows it to actually go into a high power mode. And we've also employed a high powered barrel adapter for your connection there. So that's going to give 5 volts, 4 amps of power, which generally is required if you're wanting to use like a USB powered webcam while running, say, a live object detection workload. Typically, those cameras will pull some extra ampage, so you'll definitely want to have max power mode enabled and a suitable power supply if you're going that route. And of course, you alluded to this, the case. That is it was at the time one of the only and the least expensive two cases you could find on eBay that we sort of ordered in quantity, which is nice. It has a fan module on it that is not it's not one of those smart fans that actually like knows the temperature and responds to it. It's just always on, which is good because typically you'll find with these things, once you get a workload going on it, usually you keep it on all the time. So
Yeah, and
no
some of those
harm.
heat sinks can get hot.
It's funny. I was in a certain building on the Redmond campus, and I noticed that some folks, I guess they couldn't wait to get started. Were waiting for their fans to arrive, so they were using like soda cans on top of the heat sink to keep it cool. But yeah, don't do that because well, at least you don't want water and electronics nearby each other, but or liquid of any form. But definitely employ some active cooling because you wouldn't want to damage your device while it's running some computationally heavy workload or something like that.
And I noticed the sticker with the number 24 on it. Was this part of a cluster? Tell me it was part of a
You could say
cluster.
that. No, I actually had a really good friend out of NVIDIA, Mr. Morali, who actually way back almost a year ago, when these devices were first hitting the market, I sort of pitched, hey, I think this would be something cool that we could run workshops with uh, in my day job at Microsoft. This was, of course, pre-COVID, but those were part of I want to say 30 or 35 total set that we were using touring around at different events. So that has been used in a demo at Ignite whoever attendee number 24 was. I'm sure got to use it, but I've downsized that collection just kind of due to COVID. It's hard to get these devices, get 20 people into a room, if you will, and have one of these live. So when you reached out, I was like, I've got a ton of these. Let me just go ahead and ship one out. And I'll even say here on your channel, if someone has a compelling reason to have one, I do have at least one I'm sure I could ship out. DM me on Twitter at PJDCarlo. If you give me a compelling enough reason in your first come, I might hook you up.
No, that's
Shipping
awesome.
in Malay too.
I think you may be begging for some DMs. So talk to me before we kind of jump into using it. Just talk to me really quick about what the benefits of using something like this Jetson device is over, one of the many options you have for kind of devices of this nature, these small ARM devices.
Sure. I'm trying to put myself back in the mindset of when I was first introduced to these, and what I guess is so game changing about them. There's quite a few things. I think some of it even gets lost. If I dial back really, really far, and I think when was the first GPU put on what we would call a small form factor embedded device? I'm thinking back to my college days. It would have been cost prohibitive. We'll just start there. I'm sure there were things out there, but with the dawn of what NVIDIA calls Jetson, there has been a series of devices. The Nano, the one you have, is sort of the entry level model for that. And these scale all the way up to higher level devices. In fact, the one you see behind me, this Xavier NX, is the one that was recently announced. It's 10 times the power of the one that's sitting on your desk, but approximately the same, if not a smaller form factor, which is just insane. And this isn't cost prohibitive either. The one behind me is like $400. The one you have is $99, depending on where you get it from.
I mean, and that's not bad when we're talking about needing some cheaper devices on the edge.
Oh, absolutely. What you can accomplish with it, there are things I will say. I'll put my, I will go ahead and put my reputation on the line here and say, the things you do with these devices that have an onboard GPU and that sort of thing, you cannot even meet with other devices out there. A microcontroller is not going to come close to this. An FPGA, perhaps, but also the difficulty kind of scales logarithmically with that. So, I mean, you're almost in this new class of devices that allows you to bring AI to the edge, like computationally GPU intensive types of workloads. But at the same time, in a small form factor that is capable of running those workloads in most cases real time or very, very close to real time, depending on what you're actually running.
Yeah, I'd seen some demos where it was multiple video streams that it was doing object detection on in real time off just this small, starter model.
I think we'll get to see that today. I want to say, going off of memory, the Nano can actually handle 8 simultaneous video streams. So, you can have an object detection model or whatever, anomaly detection running, and that can be taking in 8 simultaneous inputs for a $100 device. And I think if you start to slice it up that way, what's my cost per video input, then it starts to sound really, really lucrative. In fact, when you get to the higher end devices like the Xavier NX, it can handle up to 30. There's one that has an example that has 30. I think I've pushed it to 32 personally. Yeah, that's insane. I don't know if you've ever seen it. I got this neighbor next door. I'm in Texas, so people are. He's got maybe 32 of these cameras, and I'm just thinking to myself, every time I see it, I'm like, I know this works. Please let me connect this to your security system and make it better than ever.
I promise I will do nothing nefarious with all of the video streams.
Right. But what you're getting here too, if I was to look at just the specs, right? Just in the CPU alone on this device is pretty formidable. You get a 64-bit ARM, I believe, operating at 1.43 gigahertz, 4 gigs of RAM. So, I mean, just on that baseline, you have met and exceeded essentially what you would get like on the Raspberry Pi 4. And then when you get into the GPU piece of this, you're actually having a 128 core NVIDIA Maxwell-based GPU. The area of it that you see that has the heat sink on it is essentially protecting that GPU that's underneath it.
That's crazy. So I guess the next part of this is to have some fun with it. So far I've managed to, there's a getting started guide for everyone. I skipped ahead so that nobody has to sit here and watch me download images and flash them to SD cards and stuff. But all I've done is basically this first walkthrough, as well as install some additional Wi-Fi drivers to it so that we can SSH into it and things like that. I've got video capture set up on it as well so that we can share the screen. So what you're looking at is just starting from, if you follow this guide to get the SD card and everything, run updates and get Wi-Fi working, you're in the same place I am. So where should we get started?
My favorite thing personally to get started with, and there are a number of demos. In fact, you've pointed to like the getting started guide and that sort of thing. And there are multiple places to start from. The one that I like the most, the thing that personally gets me really excited about these devices, is a SDK known as DeepStream that NVIDIA releases that targets the entire Jetson line. And what it does, it will allow you to very easily create intelligent video application pipelines that take care of all of the acceleration needed on the encoding, the decoding, the actual execution of your inference model. All of that sort of stuff is taken care of for you, which having been a veteran of building those types of solutions from scratch, like in Python previously, many years ago for customers, I can tell you that this is a huge, like almost monumental burden that it lifts from you by having this all available in an SDK. Like I can't even begin to start. It was fun at the time, don't get me wrong, but I don't like thinking about writing optimized code where I think we were handling like 64. It's a project with some company I probably can't name for legal reasons, but I want to say it was like 64 different RTSP streams coming in, and like, how do you prioritize that? Because there's so many ways to slice it up. Like, grab one frame round robin and run your execution engine on that. Look, forget that. And if that sounds fun to you, then please solve that problem. It is a gnarly problem to solve. This is going to take a while, but the SDK does it for you.
Yeah, and I had seen some stuff too with DeepStream. It seems like it uses GStreamer and things like that under the hood, but it's kind of a nicer abstraction over the top.
Correct. Underneath the hood, there is GStreamer is employed here, which is also sort of coupled with a number of different plugins built around GStreamer. For example, NVIDIA builds these NV encoder things that actually take the input streams that can leverage CUDA down on the device and actually allow you to process them much faster than you would without a GPU. Which is pretty amazing stuff. So I'll actually ping this to you. I know we have a little bit of a back channel going on. Where would be the best place for me to send you a link for DeepStream?
I mean, that's a good question. I mean, you can do it, I guess, on our internal Slack if you want. If you want me to open it up on the desktop we have here, getting it to the other computer, to the Jetson itself, is another story. I think that's going to be manual typing.
I gotcha. So you could Google with Bing.
Okay, Google with Bing.
Yeah, we could try that.
All right,
that should get you there. I was able to find it by simply typing DeepStream 5.0 because we want to use the latest. This is like the latest and greatest, I think, that was announced at NVIDIA GTC recently, and that should get you started.
All right, so I am pulling that up on our Jetson here.
I'm watching your screen. I think you are close. Yeah, try the get started link right there. That should do it.
Okay.
And let's see. Sorry if I look weird looking off to the side. I got monitors everywhere.
Yeah, same thing. I have my normal streaming setup here, but then I also have like a secondary setup over here that I'm doing all of this Jetson stuff with.
I'm sure the attention's not on me anyways. It should be on the Jetson OS screen, right, which is where you're working. And by the way, this is a good thing to call out. It is not a bad idea to install these from the Jetson itself, and the reason why is you're going to have to register with NVIDIA to create an account to pull this down in the first place, and you don't want to get into the hairiness of passing credentials and that sort of thing through, a curl or something like that. I don't even know how you would do it, to be honest with you. The way they perform the authentication is pretty secure here, so definitely would recommend the easiest way. Either do it on the device or do it on another machine and then shell in or FTP, SCP it over, whatever you fancy. So you are on the right one there. You're clicking on the download the Debian package for the Jetson. So you want to make sure you're on the Jetson framework and not the Tesla.
My Gmail email that I've had since I don't even remember, that I sign up with to like just about everything. That's where all my spammy stuff goes. So if you have more spam for me, you're welcome to my email address.
Send it over. All right. I know I'm signing you up for all sorts of things. You know what I'm impressed about, Eric? You already had an account. I didn't expect that. I'm not gonna lie. So
I did, because it required me to set up an account to download the image that I burned.
Aha. Okay. Good. Okay, that is good to know. So if you've even made it to this step, provided you didn't have a pre-made SD card, then you would be ready to go too.
Oops. Excellent. I hit that twice.
And one of the things I like about this latest release of what they call the Jetpack, which is the release for the underlying OS / all the fun tools and toys that come with it, is that now you have all of the applications and software distributed through Debian installers, which is really awesome. That wasn't always necessarily the case if we go back a few years, but the Jetson platform is certainly maturing, as you're seeing here, which is pretty awesome for ease of use and ease of installation, ease of upgrades, and that sort of thing.
All right. Type in my super secure password.
TOOR. Sorry.
Hunter 2.
I'm just trying to throw in some jokes that I guess are funny or sad, depending on how you look at it.
You remember the whole Hunter 2 thing from IRC, right?
Dude, how old are you?
I'm old.
My gosh, you just draw me back until I was probably like 10.
some Merc scripting.
This was like, people don't.
Eric slaps Paul around with was it a dead trout? A very large trout?
Okay, these things are going to separate your audience, because what you have just reminded me of, and I think a lot of us have forgotten this. There was a time when memes didn't exist, and in fact, the closest things to them were IRC, urban legends, copy pasting, which they didn't call copy pasta back then. Who knows?
Yeah, I joke with my kids sometimes when they tell me stuff, and it's like, my generation invented that.
So here's what's cool. That installed. Before you close it,
okay.
There was a nice link I saw there where it was like, get started with the samples. I'll show you how I learned, because, and I apologize if any of my NVIDIA friends are out there. I've probably read the documentation. I've glossed it.
Let's see. I don't see the getting started with the
Oh,
samples.
it was right after the Debian installer finished.
Oh, in the Debian installer itself. Yeah.
Yeah, maybe if you re-kick it off, it might.
Let's see.
It's not important. My point was, I was hoping we could go see what they have to show there, but you don't need to necessarily go there to get started. I learned the hard way, or the easy way. It depends on how you like to learn. I just went to the directory where everything was installed, and lo and behold, there was a samples directory, and just started going to town. So I'd probably do the same.
Well, that sounds good.
So you're going to have to fire up a terminal if we're going to explore that.
Right.
Apologies. There was a link. So for anyone who's viewing this, or maybe even later, there was a link after the Debian installer finished to a website for samples and getting started. That may be better documented than what we're about to do. It might not be as fast, though, because you have to actually read it. And I apologize. I'm one of those people. I gloss documentation. I don't read it.
Yeah. Me too. I find, because I'm self-taught, that I like fumbling around. It makes me have to reason about things. So I often will do that, and then I'll use documentation as a reference. So somebody in the Twitch chat asked us what we're building.
Oh, we're going to take DeepStream for a spin on the Jetson Nano, which means we're going to somehow process video feeds, maybe live. I don't know if we can grab one from somewhere. We'll figure that out. Or local video files. I know the samples actually come with those. And we'll also try to show you how you can slap chop, which is a term I've just now coined.
I'm pretty sure that the device, the slap chop, coined it first.
Yes, that's right. So when you are so this is one of the other things. Not only do I gloss documentation, I like to slap chop my code, which means you take something that's already kind of there and you sort of bend it to your will or your desire, by hopefully understanding how it works. So we'll slap chop some DeepStream configs for the end of today, and hopefully show us doing live object detection with a sub. Is it fair to say sub $100 if you can get it for $99 on a approximately $100 device, small form factor device? We'll show doing object detection in near real time, maybe real time, depending on what kind of streams we can find.
Sweet. All right, so where do we find this directory?
I just want to say, Eric, I'm having so much fun brain dumping with you, because if this was me driving, this wouldn't even make sense at this point. Not because it'd be getting complex. It's just like I'd skip the whole walk, I'd skip the whole crawl, and this wouldn't make it. So I'm loving this. I just want to say, like, I'm finally feeling like all this info that I haven't shared is coming to life on your stream, and I love it. So this is going to be in WAC opt, WAC NVIDIA.
What do we got here?
And then inside there is a DeepStream folder. We'll go inside there. Now, park here for just a moment. One of the nice things that's been included in the DeepStream 5.0 release that you're seeing here, there is now a symlink directory for that's just called DeepStream, and there's also one that is given a version number. So we installed DeepStream 5.0. This symlink is actually really, really useful, because there's a bunch of shared objects and plugins and that sort of thing that are compiled against certain libraries, and your configs prior to this would usually denote DeepStream-4.0 or DeepStream-3.0. And so what would happen is the DeepStream version would increment, and your configs break, because they'd be referencing files that maybe don't exist on the system. And now you can reference them through the symlink. So you can just reference everything through WAC DeepStream, and provided something hasn't really, really broken under the hood, your stuff will still work. So just wanted to call that out. But yeah, we're going to party inside. It doesn't matter which directory you go in, because they'll go to the same place. So you can go in either of those, and that will take you to, there we go. That'll take you to a new one. I'm sorry, I'm just waiting for this blurriness to go away. Your directories, I can see everything else, but I can't see the green.
Oh,
highlighted directories.
Oh yeah, there's samples and sources that are there. Can we?
And that's on me. That's just on me because the way the stream's coming through, for whatever reason, the green stuff is like invisible.
It is quite magic how Paul and I are able to do this together. Yeah, there's an online service that I think is WebRTC, which is how we hear each other. And I'm sharing my screen through that. And he has like a browser link to my desktop screen and another one to my Jetson that's here. And he's switching tabs to see this stuff. It's much more seamless for all of you.
So we could basically do an entire episode or series, if you will, on how this thing even got up and running. And we will probably one day. But yes, it is, I can kind of see it now. So yes, you will for this next part. And by the way, just before we do this, Erik, let's be honest with our viewers here, because they're probably wondering, like, so you guys prepared this, right?
We did not prepare this, and I think that's the fun in it, right? I think that there's something humanizing.
When did you know we were using DeepStream? When did you know that?
You and I had talked about DeepStream before, and it was one of those things that
came out of the mouth, but we didn't actually agree to anything until
I don't know, 10. Yeah.
I love it. So yes, we're going to head into the samples directory, and this is where all the fun is. And in fact, this is where I learned. I learned in two places. I learned in the samples directory, and I learned in what I call the DeepStream Dev Guide. We'll bring that link up in just a moment. But I want to walk through just what you see in this directory because it's important, and it'll help you understand what's going on here. While we're fixing the font size there too.
Yeah, this is going to be way too small for everybody. So let's see what that gets us.
Yeah. Oh, I can see the green text now. I love it.
All right. Okay.
So there's a number of directories in here. So you've got your configs, you've got your models, your streams, and this TRTIS stuff. Okay. Now, we are going to be using kind of the old school based DeepStream, but there is a new support for what they call the Triton inferencing server. So that TRT or TensorRT inference server. That's going to let you run TensorFlow models, so .pb text sort of outputs. We will not be doing that today. We're actually going to be using some older, old schooler types of formats. This is brand new feature though. Just want to point that out. The streams directory is going to contain essentially local video files that these pre-baked samples might reference. Just for whatever reason. So if you're going, you see a bunch of MP4s and some JPEGs in there. If you back out and head to, we'll look at the models directory next. The models is where we're actually going to store the, that's where where the actual inference model or object detection models, if you will be stored. So if you back up one there, Erik, and head to /models. So
Are we slightly delayed?
Dude, yeah, that's what I'm thinking.
Let's see. Yeah.
Okay, I see it now. Yes. So yes, if you head back into samples. We're in samples.
Yeah, we're in samples.
Then head into models. Sorry.
Okay.
And if you ls here, you'll see a bunch of primary detectors and secondary detectors. Now, what's interesting here is that DeepStream can allow you to do what's called cascading inference. So that means that if it sees an object, you can then employ a secondary classifier or something on that. Or even a secondary object detection model on that as well. So examples of that would be, I just saw a car. Okay, I'm pretty sure it was a car. And then what it'll do, it'll zoom in on the car and it will run a secondary model. It'll be like, what type of car is that?
Oh,
or what
interesting.
is the car? Yeah, so you can do those sorts of things. There might even be some examples. A segmentation is another interesting one that will actually draw around the actual object itself, not just the bounding box, but it will actually do the segmentation of the actual object itself. Those types of models, just to clear this here, while they look amazing, especially in like presentation or demo form, they're often not real time. They're usually processed after the fact. The stuff we're going to do is going to be real time based. So if you head into like that primary detector nano, because I believe one of these that we're going to use is going to actually reference that. And you'll see this is a cafe-based model. So this model was exported in the cafe format, that cafe model. Now, one of the things I found, and someone can fact check me on this, because you got to realize I'm an IoT person that sort of stumbled into AI and ML because it's fun to run on IoT devices. But what I have found in my journey of all this, there are so many formats of models for use in object detection, ML classification, all that sort of stuff. And no one seems to want to agree on a common format. The best that we've got is this thing called ONNX, the Open Neural Network Exchange. At least it's the best I can tell. I don't know if you lose fidelity with that format. I don't know what its cons are. But there's a whole project out there. In fact, Microsoft is actually the lead. Actually, they are the developer of it, that does nothing but transfer between these various formats. So just keep that in mind.
If you have feel like this is all of tech. All of tech, we can't agree on standards. So
yeah, well, they're doing it again, Eric. They're doing it again in the realm of ML and AI. And I'm just saying, as an outsider, it's confusing. So I would love someone who's actually like an expert in that field, been a data scientist for 10, 20 years, could tell me if I'm smelling the right thing here, because it's got a weird smell to it.
What's that XKCD, situation? There are 14 competing standards. 14? That's ridiculous. We need to
that exactly. Yeah, and like some of them can interchange between stuff. So anyways, what Microsoft did, I want to say it's called MDNN or something. God, the name fleets me right now. But what they do, they convert it to an intermediary format, and then from that intermediary format, convert it to the target format. So now you know, the more you know. And this is important because one of the first questions that gets asked, like, hey, I got this DeepStream thing running and going. How do I use it with this model XYZ? While I'm not answering the question, I am explaining to you what the problem is and the type of yaks you will have to shave should you encounter that question on your own.
Okay. Yeah, I mean, I didn't realize that. I guess, from my standpoint, I'm really new to AI and machine learning, and I'm a hobbyist electronics person. So yeah, I wasn't aware of that. I mean, nowadays I hear a lot of people talk about TensorFlow, and I've helped people set up some things around Kubernetes doing kubeflow and get scaling out to GPU nodes and stuff like that. So I wasn't aware that there were multiple standards for models.
I know, and it makes me a little upset because, like, if there was one format, right, then we would have one way of doing things. But and they all have pros and cons from what I understand. In fact, if you want to bring it up, it is called MMDNN, which I'm not sure what that stands for. One would assume one of those M's might stand for Microsoft. DNN, I guess, is Deep Neural Network. Let's see. But if you head to the MMDNN GitHub repo, Mary dog Nancy MMDNN. Yeah, sorry, that's the one. If you scroll down in their README, you'll see it. It'll stick out like a sore thumb. There's a model conversion graphic that's shown here. It basically sums up state of the industry, if you will. So yeah, and that's just some of them. That's some of them. You're missing certain other formats that are out there. For example, like ONNX. I see ONNX as an output, but not an input, right?
Okay.
But yeah, you'll see, and the way that they accomplish this is some sort of they pull it down, convert it into intermediate representation. Now, I'm already getting an idea I have a feeling we're gonna get stomped on this, but let's take DeepStream for a spin with the samples,
Okay.
and then let's think as a reach, knowing what we know now about this. We'll maybe swap in a model, maybe even just something off the shelf from here, since it looks like it can convert things to cafe. And we'll play in the land of cafe for today. Although that is not my favorite. My favorite is probably the TRTIS stuff, which is a whole another segment that we could do later. The TensorFlow stuff is really cool. But yeah, we'll play in the world of cafe today.
Yeah, and if everybody loves this, like, let me know. I'll keep dragging Paul on, and we'll just keep going.
This is a good idea because, like, I didn't know what to expect. I'm telling you, I'm loving this brain dump. You're dumping like 12 months of knowledge, and we've only gone in 2 directories. Wait until we go into that samples directory and get in the config folder. All right, are we ready for that?
We're ready. Let's do some streaming. Let's hope my USB camera works. Oh, well, I guess she says there's some sample videos that we could use as well if we can't get a camera working.
Yeah, well, we're going to actually do both. And let's queue up one more link here. I've actually got this one on an AKA MS because I use it so often. I can never find it. aka.ms/DeepStream Dev Guide. All one word.
Dev Guide.
And that will take you to my favorite part of the DeepStream documentation, which is the configuration groups. This will make no sense right now, but it will shortly. So we'll just have that up for I guess, to be able to go back and forth too.
All right.
This can get you can see where this is going. So I might have alluded to this earlier. The thing about DeepStream is if you can wield a text editor, you can build an intelligent video application pipeline that has, optimization on the inputs, outputs, and inference that's happening in between.
Yeah, and so some of these things, I guess if you don't have a background in video or real-time streams, might seem confusing. The source, sync, mux, things like that. So, I guess we could, as we work through some of this stuff, we might want to point out what some of that is, just in case that's not something people are familiar with.
Absolutely. And personally, I would be really curious to see how you interpret some of this stuff, because remember, so I just glossed the document.
So prior to Microsoft, I actually spent a couple years at Comcast doing real-time video stuff. So it's not as confusing to me what these things mean, and how multiplexing actually works, how video is actually packaged, understanding a video container versus the multiplex that's inside of it, like all of that stuff. I'm pretty versed in.
Can I ask you a question about that?
Sure.
Real quick before we dive in? All right, if you were messing with real-time streaming protocols, this is like my litmus test for, like, does this person really work with this? Then you're aware that Big Buck Bunny, right, is like the only publicly available RTSP stream.
I was actually going to ask you that, if we were going to use Big Buck Bunny.
I love that 2 people in 2 different states who've never had this conversation before already knew the conclusion. I love that.
Yeah. So if you're not familiar with Big Buck Bunny, basically there's no HD video that's like completely Creative Commons for people to do some of this testing with real-time video stuff on. So this was created just for that purpose, so that there's a video available to everybody. And it's been around for, I don't even know, 10 plus years.
I just have a funny story about that. While I was working on that project that with the customer I can't name, I just remember my boss being like, "What the hell are you doing watching Pixar movies? When you're supposed to be working?" And I'm like, "Bruh, don't you know there's only one publicly available RTSP stream that you can count on 24/7, 365, and that's Big Buck Bunny." And I got good news. It's working. People don't believe that, but there's a few people will occasionally like go on the Showdown or whatever and find like an unsecured RTSP stream. But legitimate, I'm going to go on record and say the only one that you can legally count on to be there is Big Buck Bunny, and we're going to put that to use. So let's head into that samples directory.
Okay.
My gosh, this has been the most long, drawn out opening act for a presentation.
All right, so we're in this models directory. Are we going? We're going back up to samples.
Yes.
Okay.
And we're going to head into configs.
All right.
Now, I like this one. So we're going to use the DeepStream app samples. Now, there are other samples, and maybe we can try them, but we're going to use the DeepStream app samples. Now, I like the way they name these because they make sense. Now, you would think that the config file in question would be the thing that starts with config. That is actually the configurator for the inference model. The rest of them are aptly named essentially what they sound like they do. I'll translate one of them for you and you'll kind of get the idea. I'll translate a couple of them. So all of those that begin with source. So like you have source 1, CSI, dec, infer, resnet, int8.txt. That means it is a sample config that takes in one source from what's called CSI or camera serial interface. DEC, oh my gosh, sorry, I'm coming up with a blank there. Inference using ResNet. ResNet is a type of model format a neural network used in object detection. So we'll be using a ResNet-based model in int8 format, which means so how this all works.
Now, just to point out, I think the DEC is probably decode.
That's it. That is it. Yes,
because when you think about a codec, that's what that stands for, is code decode.
Every time I see it, I think decimate. And yeah, so that did not come to mind, but that is it. That is 100% it. I'm sorry. It was a long night last night. All right. So the int8 piece is interesting. So what they found with these models is that you can do this trade-off of performance / precision. So the way these things work underneath the hood, I'm going to paraphrase our own Seth Juarez, who once explained this. Someone asked, like, how do these models work? It is a series of probabilities that are essentially taken into account. Hey, I see, it divides up this region. It says, hey, in this region, I have XYZ probability. I'm going to continue going until I reach some threshold where I know it either is probably not a thing or probably is a thing. Depending on the type of detector you're using, there might be some variation of that, but it is essentially a cascading set of probabilities upon probabilities, multiplied by each other many, many times. Now, the values that are used when those probabilities are being computed can be stored as like an int8 or floating point 16 or floating point 32. Realistically, now someone can fact check me on this. What I believe they have found is that you will get a bit better precision, of course, if you go with something like floating point 16 versus integer 8, because you're using twice as many bits to represent a number when you're performing those calculations. However, it's almost negligible. So like if you drop these things down to int8, you can actually get close to the precision, but it's way faster because now if you think about like single instruction, multiple data, SIMD types of operations that are performed on GPUs, let's say you have a 64-bit register. How many 16 bits floating point numbers can you store in that? You can store 4, right? And how many can you store if they're 8-bit represented? That one's for you, Eric. You got to do the math on that.
So wait. So you're talking about 64 bits.
So if you have a 64-bit register, how many 8-bit integers could I represent in that?
8.
8, exactly. Yeah. So, and this hopefully is explaining to you how some of this magic works under the hood. So the SIMD operation can actually stuff, if you think about it, could stuff 8 of those 8-bit integers into a single register and perform an operation against another one. So say it's doing like vector math or whatever to compute those probabilities. You are now able to, in a single cycle of that GPU, perform that operation on multiple pieces of data. The textbook example of this, I know not everyone's going to be able to draw from this experience because we didn't all go to the same college and take the same class, but usually what they do is they show you this BLAS, BLAS is the name of the algorithm that's often used for like protein folding, that sort of stuff. I just remember taking this computation class where it was showing us like what is the effect of running this as a SIMD instruction versus not. And it went from an algorithm that took, given whatever our sample input was, it was like 8 minutes to run to 8 seconds when you slice it up into eighths, which would actually make it process. It's not just a factor of 8 times faster. It's actually like a logarithmic type of thing. So it's pretty amazing. And that, for those who might have wondered, I know no one asked, but is how GPUs perform these fast, insane types of operations. In a nutshell, according to me. I'm sure you ask someone else, they'll give you a better explanation. Contact my friends at NVIDIA. They probably actually know how it works. So let's a couple other things. You'll notice there's an IOU config and a tracker config. Mm-hmm. One of the things that these can do is they can take advantage of an additional workload instead of just object detection, where it'll actually, if it sees an object, it can then apply a tracker to it. And trackers are nice because the algorithm for that is low intensity and can run entirely on the CPU. So you end up in a scenario where you can see an object, and then when it goes into, let's say, the next frame, it's actually easier to find because the tracker knows where it is, and it's using the CPU less intensive workload to follow it. So that's tracker
where you see like that bounding box kind of moving around the screen when you see kind of demos of people doing object detection.
Yes, it makes it easier for it to find it in the next frame, although it is not necessarily required. So you could just be doing raw object detection each frame and not using a tracker. You'll still get results, but performance can be increased. And also what the tracker can let you know to some degree, it's like if an object is entering a scene or exiting a scene, because it'll actually assign a value to it in the output, as you'll see.
Oh, so, and I guess another thing would be if we got into like computer vision, if you wanted to see whether you're getting closer or further away from something too, right?
Interesting. I don't know how you would tell that. So like if you were zooming in and out, I don't know, but that's actually really interesting that you brought that up because it can change things. So I have seen some implementations of object detection where they'll do things like calculate the velocity of an object because they can look at it in multiple frames and see how fast it moved. But you got to understand that in order to do that, you have to have a undisturbed environment where you have somehow performed some sort of a measurement beforehand, and you're taking into account the skewedness if, say, that camera's at an angle. So yeah, all of that gets really hard. I wish there was a magic way to do it, but
plus you have your own velocity, right? Like calculating how much of the move is based on its own moving towards you versus you moving towards it. And yeah.
Right. And so what gets really crazy, like if we really wanted to think about the future here, is some sort of a combination where you're using things like the Azure Connect. I know there's that device that can actually do like the 3D scanning. Combining that sort of thing with object detection, man, like that's going to be really amazing, and you will be able to do things like that.
I've been looking for a need to buy a LiDAR too, so.
Oh yeah, these devices are great for that, as you'll see. So let's go ahead and crack. Oh, you said you had a USB camera.
I do. I've got one that I bought for a little robot I was building a few years ago. It's 720p, but it should do the trick as long as Linux likes it. I'm pretty sure I had it working in Linux before on an Odroid, so we'll
So this might just work. So let's take a look at, there is one, you'll see there, the source one USB decoder in for ResNet int 8 TXT. And just for those out there, you'll notice these go all the way to, there's even, the source 12 I don't think is meant to run on this device because it's appended with TX2. So that's another Jetson family device, but you'll notice there is one, the source 8 Nano, In fact, that one just uses video. You know what? Let's do that one first.
Which one?
Let's do that. Because we might encounter some issues with the USB. Unlikely, but we might. Let's do source 8, 1080p, DEC, Infer, ResNet. Yeah, Tab's going to be your friend on that one. Source 8 tab.
We're just opening it in Vim?
Yeah.
Source
if you can drive Vim and know how to exit it, drive Vim.
Do I not have Vim on here? Oh, I do. Why is it not tab completing source?
Now me, I'm a chump and like to just walk around with the keys. So sometimes you'll find me in Vim. Sometimes you'll find me in Nano. Depends.
We need to. That's why. Okay. I was a Vim person for almost my entire career, so.
That's the thing.
Source 8.
And I did that, Eric, where you get the keyboard layout thing that shows you the Vim keys, and there's the Vim Adventure, which is really awesome if you want to learn Vim. The problem is a use it or lose it skill. I warn everybody out there.
Okay, so which one of these are we doing? The source
Nano, FP16 Nano.
Oh, Nano. Okay.
Yeah, the TX1 is another Jetson device that it may or may not work here. So let's walk through this thing, this config file. So right up at the top, you see that application section. So that enable perf measurement is actually going to tell you how many frames per second you're processing. You might take a little bit of a hit because you're using it, but let's keep it on because it'll tell us, how much it's working. And the interval, of course, is how often it'll take that measurement. So every 5 seconds, it will produce an interval reading on that. For tiled display, so in this case, this one was alluded to as having 8 input sources. So when you run this config, you're actually going to see 8 things on the screen, and the tiled display takes care of how that will be represented to you. Okay. So in this case, it is 4 rows with 2 columns. So you will ultimately get 8 videos.
Gotcha.
Yep. You could change that to your liking, however you like. But that's how that's set up. Now these options, I've messed with these quite a bit and have not noticed that it leads in necessarily any performance increase. But that NVBuff memory type, you'll see there's different ways to allocate the memory. And this underneath the hood is using the CUDA SDK to determine how it's using that memory for drawing that tiled display. So, I usually just leave these at default, but you can use pin memory, device memory, unified, and surface array. And these are all well documented in the CUDA documentation. And one last thing, I skipped the GPU ID equals 0.
Right.
That won't really affect us here because the Nano has 1 GPU on it. But if you did have a multi-GPU setup, you could actually specify, I want this running on GPU 0, 1, 2, 3 ad nauseum.
And I'm assuming you can run all of this on your own NVIDIA devices as well.
Yes, and to varying degrees of compatibility. So I think officially DeepStream supports the Tesla and the Jetson, which ships with the Maxwell hardware. And I know I've tried, like in the cloud, you can get away with the Tesla V100s. Whether it will work with earlier types depends. If it's not specified as officially supported, I have tested things. I'm just being protective here of, I don't want to say something that may be a half truth. You would want to find out on your own if it is not officially supported. I'll just leave it at that. But Tesla series are, though.
And so here's where we get into this whole source versus sink terminology.
Yes. So in this case, your sources can be thought of essentially as inputs, and there are types. So you'll see we have a type designated there of, this one's interesting. Not the best one to introduce people for the first time, but we'll go with it. So you'll notice there's multiple options. There's the camera V4L2, which is technically a video for Linux represented camera capture device. You just basically specify, what the source is. You'll see URI, where you can specify a link to a local file using this file syntax that you kind of see down below, or an RTSP stream. Now, what they've done, they've actually used something called multi-URI, which can also be used there as well. And they're using a special syntax here to make that single video into 8 sources. It's actually going to play it 8 times. So it's not cheating underneath the hood. You might think that. It's not. The num sources equals 8. It's actually going to take that one sample video and turn it into 8. But if you wanted 8 unique videos in here and specify those as unique sources, or use a single source and use a multi-URI, which multi-URI is interesting how it works. It actually like appends a number to the file. In fact, I believe it might be what it's doing here. So there might be a sample 1080p H.264 2, 3, 4, 5, 7, 8. If we bring up that DeepStream dev guide, it'll explain this one a little better. And I'm totally dropping this. And you know what? The URI syntax, noticing there, yeah, it's got a special type for RTSP. I may have erroneously said that you can specify RTSP in the URI. You'd actually want to use type equals 4 there. My bad.
Gotcha.
So yeah, if you bring up the DeepStream dev guide, let's take a look at that multi-URI. I just want to, there's something peculiar about it. So that would be in their source group. And if we scroll down here, these are in fact all of the options that you would use there. So if you didn't see something,
I don't see. Oh, here we go.
there URI. So read out loud what it says about multi-URI. You'll see what I'm saying here. It's a little peculiar how it works. It's not what you think.
With multi-URI, the %d format specifier can also be used to specify multiple sources. The application iterates from 0 to number sources 1 to generate the actual. Okay, so it basically does an underscore 0, 1, 2, 3, 4 kind of iterating up.
Yes. That's what I was trying to convey, but yeah, it makes more sense when you see the documentation.
Yeah. Okay.
But I've never found a reason to use that. But you could I guess see why. If you named things in a numerical fashion, you could easily represent them in the config.
Well, I mean, I guess when you think about like an MPEG dash stream or things like that, right? Like you're usually iterating over these segments, so you may have actually broken it up like that. Yeah. So your transcoder may have split it up into different segments or something like that.
That's, yeah, totally. A lot of those do that for you. So yeah, that totally makes sense. It might be something you encounter depending on your setup. So syncs would be thought of as the outputs. And you'll notice, let's scroll up to sync 0, just to make sure we catch them all. Yep. So this one's interesting. So number 1 is the fake sync. And for whatever reason, you always want to have one sync designated. So like if you're pumping this data into Azure or whatever, using, there's a message broker plugin, you want to have that enabled. But we can also change it. Now, the way that it's currently configured is odd, because these config files, notice how it's specified to type 5, but it doesn't tell you what type 5 is. It's in the documentation, and we can fix this. I meant to send this over to, this is on me. I've known about this for months. I could have sent this over. So the two you want to really be aware of here to see something on your screen is EGL sync, which is type 2, which will give you an X11 based window of output. And in fact, I'm going to tell you right now, go ahead and change type equals 5 to type equals 2. Now, what type equals 5 is what's called the NG overlay, NVIDIA graphical overlay, which is a fancy way of saying draw directly to the frame buffer. So if you start this application, you'll see your objects and all that good stuff, but good luck being able to click on your UI after it spawns, because it'll be drawing over your frame buffer. It might sound silly, but it's actually a really useful feature. It's nice for multiple reasons. DeepStream can run in a container. And I don't know if you've ever tried running an X11 app in a container, but you need to forward the X11 socket, and you need to give permissions to the user running the container to be able to talk to the X11 socket, amongst other things. Right. And if your container is not spawned in that fashion, maybe you're using something like Kubernetes, where now you got to put that directive somewhere in your config. It's just not going to, you could get it wrong. And so what I like to do a lot of the times is test, especially if I'm running something from a containerized workload, I test it with type equals 5, because it'll draw to the frame buffer, meaning it will always draw. I might not get access to my device, but I'm usually not driving my device on a mouse and keyboard either.
Yeah, and I mean,
Usually
I guess in some cases that may be the device, that may be the priority, that you're not actually having a user interface to interact with.
Exactly. Now, the other situation that I use in my own, like I run all of my security cameras through the Jetson Xavier NX. It's essentially allows me to set it up in almost like a kiosk type of mode where I have a 7-inch screen that's attached to it next to the router that I can see from my bed. And because it draws to the frame buffer, like let's say my girlfriend, unplugs the device and she really wants to see the security cameras. She just plugs that thing back in. And when that containerized workload starts up, it draws to the frame buffer anyway. So it makes it really easy to use. So easy. We use it every single day. Girlfriend can unplug it, plug it back in, and it does what you're expecting. So just something to think about there. And there's another type, I want to say it's 4. There might be an example as we go below, but I think that covers everything I wanted to talk about with this sync. Yeah, so we'll output to EGL, which will give us a window that we can actually click and close versus drawing to the frame buffer. Sync number 1, that's down below there, is showing you an example of writing to an output file, which is nice because you can choose various different things, bit rate, the encoder. And this is nice if you want to do archival, archival with the detections drawn on it.
Oh, yeah. Yeah, that would be really valuable.
Well, so I don't do that myself, actually, because like my cameras, they offsite to an Azure storage, believe it or not. But what I would be smart to do is to also have a local copy and an offsite copy. So in case the house burns down, you still have a backup, and in case a thief steals the camera, you still have a backup. You gotta think about those edge cases. Sorry. So you are on an interesting one here where we're showing you also an example for RTSP streaming, and this is cool. We might set this bad boy up where you can actually expose the detections and the video output to an RTSP endpoint, which is really cool because you can like view it remotely. So like the way I do that at home, if I network in using a VPN, so to get into my home network, I can then launch up, say, VLC on my phone, and I can actually see the workload running on my device, which is pretty sweet. So it'll expose that. The RTSP port that it designates is the port that it'll serve it off of, and it'll actually, if you do enable that feature, when DeepStream starts, it'll give you the URL to connect to it. And then I want to say the UDP port is used for multicasting. So that will actually multicast all of those frames off of port 5400 across your local network, or you can comment it out and it won't multicast.
So we'd be able to open that up in like VLC or something like that.
Yes, and have multiple consumers as well due to the multicasting feature, which is cool, really cool. On-screen display, so this OSD section, this is going to basically give you ways to configure how the bounding boxes are drawing, how text is drawn on objects and that sort of thing. What fonts and colors. Stream mux. This will the mux are from what I believe this to be anyways is when it stitches all of the images together. That is the muxer. And you designate the number of batches that processes. This is actually really important if you're using live cameras. The batch size should usually, if not always, be set to the amount of input sources that you have. I've also found that using a multiple can work well here as well. So if you had like 8 cameras, you want your batch size to be 8. And the reason why is that on a single pass, that means that it's going to throw over 8 frames. And if you have 8 sources, that means when it does the round robin, it will actually go through each frame, grab 1 from each, and then pass that over for the stream mux. Because you do it in that batch size greater than 1, you're able to get near real-time performance. If you didn't do it that way, what would instead happen is you'd grab, like, let's say you use batch size of 1, it grab 1 frame from one camera, 1 from the next, or 1 frame from a camera, process, 1 frame from the next, process, 1 frame from the next. In this case, it actually sends all 8 over, And so you get like a constant stream of all 8 of those sources. Bandwidth permitting, you should not skip a beat in terms of frames.
And now, I guess to understand that a little bit, the way multiplexing works is you can think of frames coming across the stream that have a header that say, this is audio channel 1 and video channel 1. And what happens is that kind of all comes along in a stream, and the demuxer on the other side pulls out the header, looks at how many bytes this is, says, oh, this is channel 1. This is video, send it to the video decoder. This is audio, send it to the audio decoder, and then kind of timing puts them back together. That's a whole other world talking about how that stuff's done. But understanding why you batch them a certain way helps you understand that, if you batch that at, 16, that would mean that 2 frames for the same video would come through, and then the next one, and then the next one.
2 frames in the case of 8 sources. Yeah.
Right.
Yeah.
So you get 2 frames per source, essentially, because of the way it would work.
There's also, you'll see that attached sys timestamp as NTP property. That one's actually a little useful, especially if you're using live cameras that for whatever reason might not be using NTP timestamp. What this will do is it'll actually timestamp it with the system timestamp for like message processing and when it displays it on the screen and that sort of thing.
Gotcha. And I guess, and that works when we think about the way the players and stuff like that work too. You've got a series of types of frames, and I guess we could get into this in a later episode. You actually have keyframes that come across iframes, right? I, B, and P, if I recall. And an iframe is like an image. It's a snapshot. And then, trying to remember, P frames are differences from the frames that precede them. B frames are ones that leverage the frames before and after. So when we look at like a stream coming across, there's actually no guarantee that the frames come through in order. Depending on what the codec is, it will sometimes rearrange them so that the decoder can work faster. And then there's timestamps in those frames so there's a decode timestamp, the DTS, and then there's also a presentation timestamp that tells it the order in which these things need to actually go out to the player. And that's like a whole other world we can get into one day, but that's probably why this is important, is in our own output, if we have nothing that says what the ordering of these things should be, how do we relate them to each other?
Right. And dude, that was a spot on explanation, by the way. You must have definitely worked with this stuff in the past. And just to add a few things I think they're important or interesting, with RTSP, when you're taking in those frames, they do arrive over UDP. So as you were saying about them not being guaranteed in order, yes, and the reason is because the way they're transmitted. But if they do have that timestamp data with them, it is enough of a breadcrumb to reassemble the frames in the correct order. And another thing I find really fascinating, you mentioned the keyframe interval. So that is traditionally configured on your cameras themselves. So you would say, like the way mine are, I do a 20-second keyframe interval. And so what that means is after 20 frames have been processed by the camera, it will send a full frame that is like 100% of the data. But then as you were saying, it's never, when it's sending a frame, it doesn't necessarily mean it's sending a whole new frame. It can be sending the P frame, which is a delta of the change of the previous frame versus the next. Because as you've seen, especially with security cameras, like usually it's just like something's changing in the middle, right? And so sometimes these things are smart enough where they don't have to resend an entire boatload of data like they would in the keyframe for subsequent frames, because they can use that P frame to essentially do the diffing on the fly, which is really interesting. In fact, it's kind of amazing how video over the internet, like how we're doing this right now. It's kind of amazing how that works.
And I can probably drop some links. There's a couple of GitHub repos and stuff like that that are really, really good at explaining how all of this stuff works. And there's even some tutorials you can walk through if you actually want to kind of build your own video decoder and things.
Someone did that recently on this team, or the team of individuals. Uh, anyways,
I've actually been building an RTMP server. You want to talk about weird specs? The RTMP spec is insane. So, but it was built in a different time.
Reorganizing frames from anything that can, prioritizing frames, especially from multiple sources, that's a queuing nightmare. I don't want to think about that. So anyways, the primary GIE section you'll see here is for the primary detector. Now this config does not use a secondary. So we were mentioning earlier about cascading inference, like that's a car, what's the make, what's the model? In this case, we're just going to be looking at one thing. We're using a model, I think it detects people, vehicles, bikes, and road signs. Good for driving or pointing out at your neighborhood, depending on what you want to do. The interesting one here is you'll notice there's a batch size there as well. That's set to 8. And that determines when inference is executed, is it going to be executed on all 8 of those frames at the same time in that batch. And there's also another thing down there called interval. You'll see the interval is every 4 or equal to 4. Now, what I believe this means, if you set interval equal to 0, it will actually, every single frame will get processed. And perhaps because the way the Nano is in terms of its limitations, this sample config might be using an interval because that might be giving it a bit better performance. Anything that is greater than 0 for that interval will get you closer to near real time if you do happen to be experiencing some sort of latency. So to say this again in a better way, the batch size here, just like it did in the stream mux, correlates to the number of input video sources that you have. The interval is telling you how often it's going to actually execute that model against the frames that are coming in. And in this case, when a round of 4 processings of the stream mux, which I guess means 32 frames in this case because we have 8 sources, when 32 frames have been processed, it will then use the inference to process. So every 32 frames, you are processing the inference model. If you dial that down,
be every 4 frames per video, right?
Am I thinking about that right? So yes, exactly. Because the interval is equal to 4, then yes, it is every 4 frames per video. Correct. Okay. And this is really important to think about because when I was setting this up with mine, I found that tweaking that, I wanted to get mine going real time. And there's a lot of things. If you mess with batch size, use multiples of this interval, you can eke out some extra performance. And it depends on the type of model you're running. This ResNet model that we're using here, maybe we could try. We'll tweak it. Once we get this running for the first time, we'll tweak it, do some experimentation. But yeah, we'll drive it down to 0 and see if it can do near real time. And finally, you have the tracker section. So this determines whether you want to use a tracker, so that will help you, know when items are entering and exiting. And also, if you're using cascading inference and stuff like that, it can help follow that object around. And you'll notice there's multiple different types of trackers you can use. Now, these are specified in DeepStream Dev Guide. You have the MOT IOU, the NVDCF, and the KLT tracker. Those are all different in terms of what they do.
Okay.
And that, I think, is our tour of DeepStream. And
does that mean we get to see it working?
Yeah. And I know you would think, like, why do we talk about this for so long? Because while this might appear obvious, I think we talked about all the little edge cases about these sections. Man, you could shoot yourself in the foot. Like, if you
and this whole arena, right? Like, if you are new to machine learning, this can be hard. If you are new to video, this can be hard. If you are new to both, this is really going to be like, documentation is great sometimes for these things if you understand the domain, right? But you look up here, what did I just see it? iframe interval. I mean, like, if you don't have a background in video you don't even know what an iframe is, much less what interval you would want it at, right?
You might think that it's a window that embeds HTML content inside of a web page.
You mean kind of like this this browser window that is embedded in the live stream, which is your video?
Yeah. Your version of what an iframe is might differ from someone who deals with video.
So,
and this is a video.
I will put links. I think I can edit the description of Twitch later. This will be archived to YouTube anyway. In YouTube, I'll make sure to put links to some of those tutorials that actually walk through and have diagrams of kind of how these things are laid out for better understanding of the video side.
But man, you said it. If you don't have experience in that domain, I mean, I think that was a critical nugget here. Like, yeah, it might seem like you're just editing a text file, but man, it is doing some heavy lifting underneath the hood. So let's run it. Let's run it.
All right. What do we need to do to run it?
So DeepStream app has been installed onto your systems because you installed that Debian package. So if you just type DeepStream-app, then -C, which specifies the configuration. I want to use config file, and then point it exactly at that source 8 file you were just looking at, and don't modify anything else. Just as is, and push enter. This is our litmus test and our performance battery on this sucker.
Let's see.
I was just gonna say, you know what I love about you've never messed with this before, Eric.
I have never messed with this.
I'm just thinking in a pre-COVID world, you and I might have met, over an hour outside of a public live stream. You and I would have left knowing more. No one else would have been able to understand. I kind of like this. This is really awesome. Like, you're learning, everyone is learning. I'm dumping a bunch of stuff from my brain and at the same time learning, which is great. Filling it right back up as it's coming out.
The thing that I find hard about creating content sometimes too is that when you're familiar with a domain, it's often you only get the fresh eyes one time, right? Once it's kind of like me in the Go world. It's really hard for me to think about what a beginner struggles with in the Go world because I've been doing Go for 9 years. So you kind of get detached from that. So it's nice to kind of work hand in hand with somebody who's new to it, because then you start realizing, oh yeah, I didn't realize, that is confusing to people.
Well said, man. Well said. So this is starting, and thankfully. Now this is a weird thing. You'll notice that it's like running a little choppy. Mm-hmm. This is the weirdest thing. Exit it and run it again.
Is that just like due to the compiler or something?
So you're not officially compiling. What it's doing is actually model into an executable engine, which the terms I've thrown around here is it saturates the GPU cores live. Essentially, it's filling them up with the model and executing it in an optimal way. Now, on your secondary round of execution, it should be a lot faster because the engine file has already been created, as you can see here. You're getting better performance. This might be where it tops out with the Nano. Maybe. I swear I've seen this thing. Like, maybe it's my stream. But y'all can see that, right? I mean, this.
Yeah, it could be your browser stream, because I don't see choppiness in the video on my end.
Okay, then that's me then. But so you can see here, I liked when you clicked into one of them. Maybe it's easy. So we can see it's totally doing 8 at the same time. And if you click into one, you'll see there's a group of 3 people walking by, and they've got the boxes are all drawn around them. It's counting cars. And it seems to be doing a pretty good job of it too, which is and so like I look at things like this and I'm like, I don't know about you, but like, oh, did it die because the video ended? There's an option we can turn on to make it loop continuously.
All right, what's our option?
So it's all the way down at the bottom. You're going to add a test file loop equals 1, something that let me look at the appropriate syntax for that. So yeah, open up that same file, and it's going to be way down at the very bottom. Okay, you'll add this. Sorry, I might have a delay on my screen.
Wait, what am I adding? Oh, it's in the config file?
Yes, sorry. Yeah, well, that wasn't a flag. I'm sorry. That wasn't.
And which part is it? Which section?
Go all the way down, and you'll see a section that says file loop, and it's probably currently set to 0.
There we go. Yep. One.
So file dash, yeah. Yep. And now it'll run forever like that. So if you ever wanted to, make a cool demo, or, for those of you who have kids that want to make something really awesome, and for the science fair, you want to leave this on loop. That's how you do it. So yeah, I'm just noticing like that performance seems so much better on my side, anyways. Maybe it was the stream earlier. So you can actually look to see in your output how many frames it's processing, because we have that perf interval set up. But I look at demos like this, and I just can't help but think, like, dude, just this. Like, let's say you didn't modify this. You use just this model on its own. How many problems can you solve with a thing that can detect people and vehicles? Just that. Let's just brainstorm on this for a minute. In fact, if we've got people that are tuned in, I'd love to hear your ideas here. Like, what can you do with just that?
I mean, there's tons of stuff. Like, I think we joked about an idea I had. I've had a few of them.
No, actually, I really like that one. I think that should be the reveal. Yeah.
Yeah.
Let's start with that one. I love it. How to blame the kids.
And I also dropped a link in the chat for a like a digital video introduction that's really good. And the same guy also has another one that's really good. It's like an FFmpeg libav tutorial, but if you're not familiar with kind of like container formats and transcoding and adaptive streaming and things like that, that tutorial is also interesting. It's in the Twitch stream for you. Yeah, and I don't know whether you have it open or not, but especially that first one, that digital video introduction, even talks about the way our eyes perceive things, and that we actually can't tell the difference sometimes between color. And yeah, it's a really, really good introduction to video.
So curious, do we get any suggestions in the chat on what can you do with just the ability to detect people in vehicles?
Aaron Schlesinger says traffic congestion control or security camera analytics of some kind, maybe.
Everyone hates traffic. So yeah, you can maybe solve traffic with this. But also like occupancy. Yeah. Also, just as you were mentioning, the being able to tell, like, are things where they need to be, or security, that sort of thing. Like, I just look at this and, like, I don't know. I think about Highway 59 in Houston, which I'm sure anyone, wherever you are, you can insert highway number, whatever. There's one you despise. And I think two things. One, boy, would my local government like benefit from being able to have something like this implemented. Like, holy cow.
Yeah, and you think about all of those little there's a name for them, the little ropes they put across that count cars when you run over them. Like, I imagine the wear that those things suffer and how expensive and time consuming those things are to put in when they could just drop cameras. And
I got another one for you. Here's one. Now I'm being.
Oh, I like this one. Aaron says maybe you could tell if someone crashed and alert the ambulance automatically.
There you go. Yeah,
I like this. One of our colleagues also, I think when he was a CSC, told me for the Canadian Coast Guard, I think they use something like this to detect life vests in the water, that it was easier for the computer to recognize that it was a life vest in the water rather than the human eye when helicopters flying over.
Yeah, it was Anthony Bartolo. I want to
Yeah.
say he delivered that at Build last week. Quite a sweet project, and also just like awesome problem domain.
I just noticed it is 3:30 and I have a meeting.
Now,
Now. I mean, I can jump back on later today. I mean, maybe we could continue this a bit tomorrow as well.
this is not a bad stopping point,
Yeah,
is it?
it all culminated in seeing it work. But yeah, this is my one-on-one with my skip manager. So
Oh, I got you. That's important. They'll understand. Tell them you were leaving a live stream. It was just getting hot,
yeah,
and we'll come back.
but yeah,
And for those of you in the chat, let us know what you want to see on the next one. Maybe we'll try to help think of something beforehand, because this was fly by night. So
yeah, I think we should definitely continue this. I would love to just keep kind of building on top of this.
one of the other things I was thinking here too, those Amber Alerts, man. Imagine if you had a system that could tell you that the vehicle that you are looking for in that Amber Alert
Is a white Chevy pickup truck, and it's just counting it.
it's always that white Chevy pickup truck. Someone needs to stop that person. All right. On that note, it's been a pleasure.
Yeah, this has been a lot of fun.
Erik, for having me, man. Like, wow, I would do this forever. This is fun.
I think we should do this forever. Maybe we can set up like a weekly or bi-weekly thing where we just work on this stuff and other IoT related things. I've got an office full of parts that are in need of being played with.
Well, all right. I know what we'll do. When we come back, we will slap chop this thing. We'll process Big Buck Bunny. We'll maybe get your USB camera working. We're going to do all sorts of stuff. Maybe even show you how to make it detect whatever you want.
Perfect.
We'll do all of the things.
I am super excited. Well, thanks for joining me and walking me through all of this. This is going to be a lot of fun.
You bet. My pleasure, Erik. Enjoy your meeting. Good luck. And thank you, everyone out there, for tuning in.